Okay, let's talk about antiderivatives. And just like it says, these are the opposite of derivatives. So the question is, if I would start with something like, say, 3x squared as my function, let's go back up here and say, what function is this 3x squared, the derivative of? Okay, now how do we take a derivative? We bring the number down in front, bring the exponent down, and we subtract 1. So that degree 2 on this has to be 1 less than where it came from. So let's guess x cubed. Well, if you take the derivative, you bring the 3 down, and you subtract 1x squared, that's what that works, okay? So 3x squared is x cubed prime, but so is x cubed plus 2, x cubed minus 4, x cubed plus square root of pi, x cubed, or square root of 5, plus pi, because the derivative of a constant is 0. So the antiderivative, or the general antiderivative of 3x squared is x cubed plus a constant. Okay, let's look at another one. What about x? Where did x came from? The derivative of what function? Again, when you take the derivative, you bring the power down and you subtract 1. So to go up, I'm going to add 1. Okay, so far that's x squared, but x squared prime is 2x. So I have to get rid of that 2 by multiplying by a half. So the antiderivative of x is x squared over 2, or 1/2 x squared, same thing, plus a constant, and here I have to add on the constant. So the antiderivative just takes everything, takes it backwards. Okay, so the most general antiderivative of x to the nth is x to the n plus 1 divided by n plus 1 plus a constant, or 1 over n plus 1 times x to the n plus 1 plus a constant, because the derivative of a constant is 0. So the concept is, what function derivative gives you this function here? This will be called, inside here, will be called the antiderivative. This function inside here. Alright, and let's talk about cosine, the antiderivative of cosine x. So if I take the derivative of cosine, the derivative is minus sine. So when I go backwards, what gives me, what is the derivative, when I take a derivative of what function, I get cosine. Well, that's going to be sine. So sine x is the antiderivative, and the general will be sine x plus a constant. The antiderivative of sine x Okay, here I have sine x. The derivative of sine is cosine, but the antiderivative means I have to take the derivative of it to get positive sign. There's going to be negative cosine x, because the derivative of cosine is a minus sign, and that negative and the negative is going to have to give me a positive sign. So that's going to be minus cosine x plus a constant. Okay, so let's look at some examples. The antiderivative of x to the fifth. Well, I add 1 and divide by that exponent plus a constant, or 1/6 x to the 6th plus k. And to check it, just take the derivative, bring the 6 down. 6 times the 6 is 1. Subtract 1. Derivative constant is 0, so I get x to the 5th. It checks. So whatever I'm taking the derivative of is called the antiderivative. Now, if I just have a constant, the antiderivative of a constant is going to be, well, actually, let me go back here. That constant is the same as constant times x to the 0, because anything to the 0 power is 1. So when I add 1, that's 1, and divide by that exponent and add another constant, I'm going to get a constant x plus c. So if I'm taking the antiderivative of a constant, I just need an x, and then of course I always add another constant onto it. So the antiderivative of a constant, I need to multiply it by x. Okay, 2x, that's just going to be 2x, 1 plus 1 is 2, so I divide by 2 plus the constant, and that's just going to be x squared plus the constant, is the antiderivative. And so the point is if there's a constant in front, I can just leave it alone and deal with the x terms. If I have addition or subtraction, I just take the antiderivative of each term, and you can look at the rules for that. So I'm just going to take the antiderivative of each one separately, and that's going to be leave the constant alone, add 1, and divide by the exponent, move on to the next one, leave the constant alone, add 1 and divide by the exponent, leave the constant alone, add 1 and divide by the exponent. The derivative of a constant, I just need an x with it, so that's going to be 1x, and then I add another constant onto the end. So this is going to be 3/5 x to the 5th plus 7/4 x to the 7th minus 2/3 x cubed plus x plus the constant. Now don't forget to add that constant onto the end. It's really important. Okay, what about 1 over x squared? Well, the trick here is to rewrite that as x to the minus 2, so it's x to the nth form. Because the only formulas we know right now are the ones for x to the nth and sine and cosine. Okay, so that's going to be, the antiderivative is going to be add 1, that's going to be negative 1, and divide by that exponent and add a constant. So that's going to be negative x to the minus 1 plus a constant, or negative 1 over x plus a constant. Okay, so that's really important. What about square roots? Well, you rewrite that also. That's going to be x to the negative a half. Negative because it's in the denominator, a half because it's a square root, and that's x to the 1/2. Again, we rewrite that to get it to be x to the nth power. Okay, that's the idea here. So now I can use the formula where I leave the constant alone, I add 1. When I add 1, negative half plus 1 is a half, so, and I divide by that same number. And on the next one, I add 1. That's 3 halves, so I divide by 3 halves. So remember, when you do the antiderivative, this exponent and the denominator are going to be the same. This exponent and the denominator are going to be the same. Okay, now let's simplify that. I invert and multiply a fraction, so really I'm going to multiply by 2. So 4 times 2 is 8, x to the 1 half, plus 2/3 when you invert and multiply. And that is 8 square root of x plus 2/3 square root of x cubed plus a constant. Okay, now how do you check it? Again, you just take the derivative of that. So let's take the derivative real quick. That's going to be 8 x to the 1 half plus 2/3 x to the 3 halves plus a constant. The derivative of that is bring the half down. Half of 8 is 4. Subtract 1. Bring that down. That's going to be 1. Subtract 1 plus derivative constant 0. So that's going to be 4 over the square root of x plus square root of x. And that checks. Okay, this should be your original function. So this is the antiderivative right here. That's our answer. So you can always check your answers by taking the derivative of what you get and seeing if that's the same as what you started with. What about 6 cosine t? The antiderivative, you leave the 6 out in front. The antiderivative of cosine is sine, and then add that constant on. Okay, so that's the antiderivative. I'll just say AD. Minus sine t over 4, well, that's the same as minus 1/4 sine t. So the antiderivative, I just leave the negative 1/4 out in front. The antiderivative of sine is minus cosine. Remember, it should be the opposite of the derivative, and that's going to be 1/4 cosine t plus k, or cosine t over 4 plus k. Okay, so let me just give you the definition. F of x is an antiderivative of f if f prime is equal to f. So this function in here, the capital F, is the antiderivative for all x in an interval. The most general antiderivative, which is what we're looking for, of f is f of x plus a constant. Okay, so you can't forget to add that constant because the derivative of a constant is 0. Now, what is this good for? Well, if we start with the function, the distance function, distance away from the ground, or distance, if it's a particle moving in a straight line, distance away from where it started, and we take the derivative of it, we get the velocity. Or, well, it's not the same as speed is always positive. Velocity can be positive or negative. If we take the derivative again, we get acceleration. So if we go backwards this way, we see that velocity is equal to the derivative of distance, which means that the distance function is the antiderivative of velocity. And the velocity function is the antiderivative of acceleration. Okay, so look at some of the sample homework problems and see how that's incorporated into your homework.